So now we're going to talk about similarity and perimeter. So if you know two triangles are similar, then the measures of their corresponding perimeters are also proportional. And they're proportional to the measures of the corresponding sides. So not only can you do the corresponding sides, but you could also do the perimeter. So looking at an example here, it says the perimeter of RST is 9 units. So here's RST. I'm going to say the perimeter equals 9. And they tell us right here that triangle MNP, the top one, is similar, that's what that symbol means, similar to RST. Find the value for each variable. So we know that the perimeters are going to be proportional. So if the perimeter of this is 9, let's find the perimeter of this. 6 plus 3 is 9, plus 4.5, that would be 13.5. So the perimeter of this one is 13.5. So now we can set up a proportion, because we know that the sides are proportional. And so it looks like MP goes with RT. First to last, yes. So this to this will equal perimeter to perimeter. And so doing that real fast, I would say 4.5 that's a weird 5. 4.5 to Z. I could do better than that. 4.5 to Z is proportional to also the perimeter, so it'll be to 13.5 to 9. So the perimeters are also proportional to the sides. So then I could cross multiply here, and I could take 4.5 times 9. So I'm cross multiplying, that's 40.5. That's going to be equal to 13.5 times Z. So to find Z, I would take 40.5 divided by 13.5, and that is 3. So Z equals 3. So then over here, I could put that this is 3. Alright, now I can do the same thing. We could keep the perimeter part the same, 13.5 to 9, but now we want to find X. So we're going to do MN, but this and this should be proportional. So 13.5 to 9 should equal 3 to X. So 13.5 to 9 should equal, so 13.5 to 9 should equal 3 to X. We'll then cross multiply. You get 13.5x is equal to 9 times 3, 27. Divide 27 by 13.5, and you get 2. So now I know this is 2. Now we could set this up again, or I could recognize that 4.5 divided by 3 is 1.5. 3 divided by 1.5 is 2. So if you take all of these sides divided by 1.5, you get the other measurement. So let's just take 6 divided by 1.5, and I get 4. Now I get y is 4. And if you see, the perimeter is 9. 4 plus 3 plus 2 is 9. So they asked to find the value of each variable. I would say x is 2, y is 4, z is 3. Okay, on this one, they tell us the triangles are similar. They say that KQB is 72, the perimeter. So I'm going to make a little note of that. That this perimeter is 72. And then might as well find this perimeter. And if I add up the sides, that'd be 16 plus 12 is 28, plus 20 is 48. I'm going to do this problem a little bit easier, I think. So we're going to take 72 divided by 48 and see what that is. So if I take 72 and I divide that by 48, I get 1.5. So what that means is, to go from small to big, I just multiply by 1.5. So then it becomes much easier, because I could take 16 times 1.5. So 16 times 1.5 is 24. 12 times 1.5 is 18. 20 times 1.5 is 30. And so if you add those numbers, you get 72. So I think that probably is a lot easier than setting up a proportion, when you just take perimeter divided by perimeter, and that's your scale factor. So I took 72 divided by 48, I got 1.5. That means I could take each of these sides times 1.5 to get these sides. Now we're going to talk about something called scale factor. And the scale factor, they're wanting to know the scale factor from here from here to here. So from here to here. So we would take 9 divided by 15, because those two go together, and I get 0.6. So then I would say the scale factor .6. In other words, if you multiply 15 times 0.6, you get 9. If you multiply 10 times 0.6, you get 6. And if you multiply 20 times 0.6, you get 12. You may also see that written 0.6 is the same thing as 3/5. So that's what scale factor is. I think that's enough.